All right, team. Good evening. We are getting ready to get started with the last bit of level 2 work. Let's just get rid of all of this. All right. Yeah, just had a quick look through doc. Now we're not going to be doing algebra today because I did say to a few people that I'll be doing probability today. So definitely going to be doing probability and nothing else. If you are wanting to do algebra and calculus, yeah, you've you got all the. I think I spent like 2 hours yesterday. I'm shattered today, so I'm probably only gonna do this for about an hour, and then because I gotta get ready for school tomorrow as well. I'm at OJC Met. No, this is not calc. I'm sure I wrote it down as probability. Yep, definitely probability. The exam paper that I've picked up is from 2019 again. This is Cohere 2019. So I've got a few questions that we're going to go through. And what we'll do is the usual. I'll put the question up, give you people a few minutes to answer those questions, and then we'll actually go through them. All right. Now, if for any reason you're sitting there going, it's like, oh, can we do these questions? Can we do these questions? If it comes in the exam paper, then we will do them. Otherwise, I think I won't be able to create on-demand questions at the moment for people. So yeah, just kind of keeping that open there, that I've got a set questions that we're going to go through, and then we'll go from there. All right, and also if chat goes a little bit too crazy, I probably will put on slow mode so that we can I can actually answer questions mainly. All right, so the first question that we are going to be doing is, what do we have? We've got there is like 3 parts to this question, so I'm going to put all of them together. So that we can kind of do them all in one shot and then go from there. It's laggy today. All right, so those are the 3 questions we're going to be, we're going to start off with, and then we will, I'll give you guys maybe about 3 to 4 minutes to answer these 3 questions. The first 2 are achieved, and the third one is a merit. Yes, this is level 2 probability. I don't know who Shimi is. People have like weird names and you expect me to know them from those weird names. Oh, I'm glad it was 1 week of. That was a pretty fast week, hey. I think one of the questions following after this one, Hoop Angel, is a probability tree question. I'll go through the answer at about 8:06, guys. So 8:06 is when I go through the answer, based on my time here. No lag. That's good. I get these questions. I had a person that actually used to make these questions, so they've given me rights to use the questions but not share it, so that's why I can't share this theoretically as a whole exam paper. Maya, normally the day before the exam I don't do a live stream because it actually is a hindrance to people than supporting people, because people just come on the chat just to be stressed as hell, so, and people just start panicking. So I don't usually do level, like if it's level 2 exam on Tuesday, I probably will be doing level 3 or level 1 tomorrow, not level 2. Yeah, Lena, your exam is at it should be at 9:30. Generally, hoop, like practice exams do tend to be a little bit more trickier. All right, so let's start going through these questions. So looking at the first question, it actually says, what do we got? We got a survey, a bunch of data, particular Wednesday, month of March, yada, yada, yada. What proportion of year 11, 12, and 13 students travel to school by car? So, year 11, 12, travel by car, I think. What do we have? Why am I stuck in this? Like, how can I get stuck in the first question? What proportion of year 11, 12s? What did you guys get for first one? I'm already stuck in the first question. I think I've just been doing too much algebra and I can't actually, my brain's not working. Yeah, that's what I thought. Travel to school by car. I mean, if you think about it, you got 981 altogether. Why are we getting so many different answers? Yeah, see, that's what I thought. I mean, you would get 65 plus 45 plus 70 equals 180. Those are the kids that are, and then that's out of 981. Is that what you guys got? Hang on, give me a second. I've got a bug here. Like, I've either got the wrong answers for the wrong one or my head is not working. Give me 1 second, team. Let's have a look. Am I looking at the right paper? Yes, I am. How could we end up getting like the first one mess up? 180 by 293, some people are saying. Let me just have a look. Kitty cat, it happens, you know, when you've been doing like non-stop maths for like almost 7 days now, you start seeing things differently. We got so many different answers. It's hilarious. So what proportion of year 11, 12, and 13 student by travel by car? Now, if you look at what proportion, shouldn't that be the total of year 11s, 12s, and 13s? So that should be 180. Let me just do this. I'm looking at the wrong one. Let me try this. 180 divided by, you've got, how many do you have in 218 plus 183 plus 163? Shouldn't that be the answer? 0.31. Yeah, that's what the answer is. Sorry, I need to wake up from this game. All right, let's go. So we got what proportion, right? So we got what proportion of year 11, 12, and 13. So that's going to be from this group, traveled by car. So that is this. So we're going to get the blue, which is 180. and that is out of the green, which is what is it? What do we got? 564. And that's going to be 0.319. What proportion of all students walk to school? So what proportion of all students walk to school? So that's going to be 254 out of 981. That should be part 2. Proportion, probability, the kind of the same thing. It's just asking for a different one. All right, so next one is we're looking at given that a student rides the bus to a school. So if you look at it, when we say given, then we're looking at this 311. So that's the number of students ride the bus to school. What is the probability that they are a year 11 student? So we're looking for that they are a year 11 student. So that's going to be that. So you should get 66 out of 311. 66 out of 311, that is roughly 0.212. So grades wise, yep, achieved, that's an achieved, that's a merit. Yeah, no, Flynn, that was one of those questions where the 564 is actually from here. I need a different color. Mrs. Fowler. I gotta give me the first name, Ethan. I can't remember. Like, usually I remember folks with first names. All right, that's nice. M1 there. How do you know when to use 311 or 218? 218 is all of the year 11s, Mehak. But if you look at it, it says given that the students actually ride the bus to school, so that you got to look at all the number of people that take the bus, and that's 311. Well, Gutsy, I got the first one wrong as well. I was kind of half asleep for that. All right, let's go to the next one. Next question. I still have to kind of, give me a second. I just need to kind of jig this question here. So control copy, control V. This is part 4 of this question. And it is an excellence question. So still the same question, but there is part 4 for this, and they're asking us this part here. This is a Cohere paper from 2019. Chris, we've done quite a few bit of maths over the last kind of 3 days, so I'll give you folks maybe about 3 to 4 minutes for this. Now, in this particular question, even if you find parts of the probability, then you can actually get achieved and merit for it. So it's worth kind of giving it a go. Don't just kind of leave it. And also you got to justify your claim on God. You can't just say false claim and be done and dusted. See you, kitty cat. Good luck for your exams. This is Kohia 2019. Shiny, you can do the exam questions. That's the next best bet. Year 9 bus divided by total. No, Taj, the other way around. You've got to look at it. It's the claim was given that they're year 9, they take the bus, and then given that they're year 13, they take the bus. So I'm gonna work this through right now. It says a claim was made that year 9 students are twice as likely to travel by bus. So the way we write this is we're looking for the probability of they take the bus given that they're year 9, and we're also looking at probability of they take the bus given that they are year 13. All right, so there's two probabilities that you need to find for relative risk. So this is the first one we're going to do. So if you look at the total number of year 9s, that is 212. So just to give you an idea, this is the year 9s, which is 212. Then we've got to figure out from there how many actually took the bus, and that's going to be 73. So your first probability is going to be 73 out of 212. Then your second probability is you're looking at year 13. I think this is not good. So year 13, who happened to be 163. So that's the year 13. Then from the year 13, who takes the bus? And that's going to be 41. So your second probability is going to be 41 out of 163. So just kind of highlighting those colors there just to see where those numbers actually came from. Now, if you were to do this and you put the two both risks correct but insufficient conclusion. So if you find one of them, you actually get an achieved. So if you do one of them, you get an achieved, and if you do two of them, you actually end up with a merit. Now, a good idea is to put the probabilities. So I am going to just work out the probabilities, which is 73 divided by 212. So that's 0.344. Actually, I should have gone with a different color. Now, the question always people ask me is how many decimals do I go? I'm going to go with 4 just because I can. I mean, there's nothing wrong with going more, but like, yeah, I would keep 4 in this case, 2515. Okay, now what the question is asking is the relative risk. So it's saying it's twice as likely. So that means if you do the probability of bus given year 9 divided by probability of bus given year 13 should be 2. But let's try this out. So if you put the two probabilities on top of each other, so probability of bus given that they're 13, you're going to get 0.3443 divided by 0.2515. So when we do that, then what happens is we're going to get what we're going to get. We're going to get 3443 divided by 0.2515. What have I done wrong? Oh, I forgot the decimal point. I was wondering why this is look a bit weird. There we go, that's better. So it should be 1.37. So we can say that this claim is not true because claim not true as relative risk is 1.37, and yeah, there we go, that's enough. So when you write the conclusion there, you end up with your excellence grade. Kitty cat, it could be different, like sometimes yeah, sometimes it actually works out and sometimes it doesn't. So the final, I don't think it matters, Jeffrey, because you can just go, because it's a relative risk, you either want it like either it equals to 2 or it doesn't equal to 2. So yeah, you can't really kind of how do you say it? Yeah, I don't think it counts too much. Well, relative risks generally are those questions. All right, let's look at the next one. Oh, this is the typo. All right. Next question. What's the time? 8:20. That's fine. We got plenty of time. Just a quick question. Like, I've got kind of similar type of question here. Do we want to do another type of relative risk question or move on to tree diagram? Because the next set of questions is tree diagrams. Shouldn't have asked. All right, we'll just do one more quick relative risk one, but I'll kind of do it so it's just the... Okay, so I'll just do the excellence question because I think it's like, I mean, you guys get the hang of it with those questions anyway. So here is just the excellence question coming up for the next relative risk. Team, just give me 1 second. I'm just going to restart my tablet, but what I'm going to do is I'm going to just put the... Yeah, I'm going to put the question here. I'm just going to restart my tablet. Why do you do this? Yeah, there we go. And while you guys are doing that, I will quickly restart the tablet because I'm massive issues. We'll get to the tree diagrams next, people, but we'll just do this last question and then we'll get to the tree diagram. if they're both the same potato chair, then have a look at the claim. Whoa. What's that? Much better. All right, team. So we are going to go through this next question here. What I might just do is and I kind of did this yesterday because chat just got a bit too crazy on YouTube. So I'm going to have to chuck on slow mode. Customization. Let's go 60 seconds. There we go. All right, so let's have a look through this question here. So what we've got here is, first, now they've claimed that the females that walk to school were equally likely to travel by bus to school as males in the survey. So first is when we write this as a probability, we can say that probability that someone, given that they were a female and walked, that's one of the probability. And the other one is we're equally likely to travel by bus to school as males in the survey. So we want to go probability of bus given that they are males. All right. So those are the first two probabilities that we're going to actually find out. So from here, we're going to look at the number of females that... What do you got? Number of females. Where is the 254? Why is my table looking a bit munted? 118 out of... So if you look at how many females... My God. I'm stuck here. We don't actually say anything about year levels, eh? So that's everybody. So 118. Have I written this wrong? What about bus? Bus is 311. I think I've actually written this wrong. School claimed that females that walk to school were equally likely to travel by bus to school as males. I think I've written this wrong, team. So that would be females given people walk, and that should be probability of males given that they take the bus. So if we look at the total number of bus people, that is 145 and 166. That's going to be 311, and the top line is going to be 145 because that's the bus and males. Then for female and walking all together, you're going to get 254, and females is going to be 118. So the 254 actually comes from 118 plus 136. All right, so with that in mind, we got 118 over 254, and then we've got 145 divided by 311. And so if you look at the probabilities, they should, looking at the relative risks here, 118 over 254 is 0.46, 4644646. Then you got 145 divided by 311. That's also going to be 0.46662. So no, that's what I thought, but I think it's the wording of it. Like, if the wording of it is, let me just grab it. I just want to see if I can get this correct, the right wording. Yeah, I know it looks easy, but it's like I keep stuffing up the words. See, Kutappan, I actually thought it was the other way around. It was like we're looking at the whole group that walked, and from that group we looked at the females, and then for the whole group that took the bus, and that from that group we looked at males. What were you thinking? Females, bus walk? Nah, it's a different number. It's interesting because I got a different answer for why would it do that? Yeah, Jeffrey, I think you might be right on that one, right? Like, I think that's how that would be. Sorry, I didn't look at the comments on TikTok. I'm on two kind of channels here. Now the final answer that you're gonna get is, when you look at it, it's equally likely, because if you take those two probabilities and you divide it by each other. So if you take 0.4662 divided by 0.4645, it's almost equal to 1, and because it's almost equal to 1, we can say that it's almost, well, it is equally likely. So we take both of those and we divide it by each other. Actually, no, I did this one. 4662, 4646. That's going to give me 1.003. So I can kind of say that this is equally likely because it's so close. So claim is justified. Hi, Mrs. Smith. Sorry, Hav and Hoko. All right, let's get going to the next one, because I think we'll go to some probability trees. I mean, you could do this in probability trees, but where is it? Where is the question? So we're going to go to probability trees now, and it's a pretty like meaty question here. Welcome to my street. I've got a lot of fireworks happening here. No, Ella, these are questions from this place called Cohere. They used to make questions before. So, all right. If students play one game. Hang on. This is question A, isn't it? Yes. I'm looking for another probability tree, but weird. This question is like a huge question, and I just having a look at the marking schedule from back in the day. We've got we've got a massive E question right at the start of question 2A, which I don't think it usually happens. They tend to be a little bit more easier. But if you draw the tree, then we can kind of slowly try and work it out. I'm gonna start chipping away at the tree. Sorry. Yeah, that was fun, sport. Now, Ishtamba, I didn't actually put this week's yet because I think most of the guys knew that we were going to do level 2 probability today. Tomorrow, I'm going to take a little bit of a break because I know that it's a bit of a madhouse for level 2s. Lockie, I think as you do more of these questions, you kind of get used to it. That's part of the reason, like, I mean, I don't do much probability at all because I hate the word questions. So I like doing complex number, like calculus and algebra before. Oh, you're welcome, Olivia. The problem is I can't concentrate as well as you go into a train of thought and then a couple of fireworks goes off. Yes, Olivia, there should be the exam videos are in it, and then the level 2 probability in 10 hours playlist is also there. Will I do an inverse question? Let me just have a look if there's any other inverse questions that are coming up. Looks like there's an inverse question coming up. All right, I'm going to start doing this question, team, because we just need to figure out. So in this one, she's got like a success rate for each one of these 3 games, right? Now, each game is randomly created. She finds that she could play 3 games while having a break from her homework. That's annoying, this one. Does it actually say each game is randomly created? If the student plays 1 game at each level, what's the probability she will complete 2 of them successfully? So can we do something like this? So this is going to be the beginner's level. So that means you're going to get 0.95 and 0.05. So that's like, so win, loss. So we're going to get 0.95, 0.05. Then she plays medium level. So win, loss, win, loss. We're going to get 0.82, 0.18, 0.82, and 0.18. Then we do the hard level. Win, loss, win, loss, win, loss, win, loss. Now the hard one is 0.75, 0.25, 0.75, 0.25. Yes, Elizabeth, it'll get saved as a YouTube video. All right, so what we then have is we're looking for, she's playing 1 game at each level. What is the probability that she'll complete at least 2 of them successfully? So that means she needs to be winning 2 games or 3 games. So if you look at the branches, we're going to do this one. We're going to do this one. We are going to do, what else? How many branches do you see? Win, win, win. Oh, there's also another one here. Win, win, loss. And then loss, win, win. So if you look at those particular branches, she is going to win. In the first one, it's triple win. Win, win, loss. Win, loss, win. And then loss, win, win. Everywhere else, she actually ends up losing 2 games. And I think the wording is important here because they do say complete at least 2 of them. Great question, Bhairav. I don't think it matters in this case because even if you go hard first, medium first, and beginners last, those 3 probability is, I don't think it's going to make a difference in this case because there's nothing that says her win rate is going to change if she plays a beginner game or a medium game or anything like that. Emma, yes, sorry, this will be posted on YouTube, so you can always catch up with it later. No worries, you're welcome. All right, so with that in mind, what we're going to need to do is we just need to work out these 4 probabilities because we've got 0.95 times 0.82 times 0.75. We're going to plus 0.95 times 0.82 times 0.25 plus 0.95 times 0.18 times 0.75 plus 0.05 times 0.82 times 0.75. So we've got those 4 branches. We've got to multiply those each of those branches and then add them up together. And I think this is going to be a pain to do, but 0.95 times 0.82 times 0.75. I'm not even typing in. Where am I typing this? 0.95 times 0.82 times 0.75 plus 0.95 times 0.82 times 0.25 plus 0.95 times 0.75 plus, I hope I did this right, 0.05 times 0.82, 0.75. All right, so I should get a probability of winning at least 2 games is equal to 0.938. Yeah, Jax, I think you might have missed a little branch there somewhere. I'm wondering. All right, so now it does say justify your answer clearly stating any assumptions that you actually make. This was one of those really weird questions. Like, actually, they had an excellence question right at the start. But if you were to just if you were to get the probability and just do the probability only, you are looking at just an achieved. But if you get the correct probability and actually give one assumption, because I think the really important part is the justification part. So you have got to say that one of the assumptions could be like, I think Bhairav asked, why would you put like beginner, merit, beginning, medium, and hard in that level? So we're actually assuming that probabilities are going to be the same. So the probabilities stay same regardless of when she starts playing that game. The other thing that you could also say is like the probabilities are independent, which is something that you probably wouldn't have heard of, but it's more like saying things like, it doesn't matter what the first result of the game, the second result has got no connection. So that's another thing that you can say as well. Eleni, as long as your final number 0.938 comes out right, then I think you've probably done it the right way. Hoop Angel, because she loses the beginning one but wins the medium and hard level in that bottom branch. You could argue that Bhairav, but like I think it's independent of any game result. Like I think depending on what so the probabilities are staying the same regardless of when she starts it. But then you could also say, like, in some questions, if she wins a beginning game, then a medium game probability increases and stuff like that. So all right, what are we at? I've got a couple of more questions that I want to do here. All right, guys, we're gonna do a couple of normal distribution questions, and then we're gonna call it after that. Just looking at the normal distribution questions. So let's stack this normal distribution questions, and then we'll actually go through it. I'm probably going to put all the normal distribution questions together in one shot so that... Yep, that could also be an assumption there, professional. Oh, sorry, did I miss Isabella's question there? What was Isabella's question? So are we saying that W is greater than 2? Kaya, we don't write W is equal to 2 in that question because it says at least 2, which means she could win 2 games or she could win 3 games. All right, here's your next lot of questions. So all 3 of them, I'm going to stack them on top of each other. So, and I think we've got a couple, 1 achieved, a merit, 2 merit questions here. And then after that, we're going to do a standard deviation question. Yeah, Mimi, I would I would fourth it, like that part 10 of it, of that probability level 10 playlist, level 10 in probability in 10 hours playlist. The level part 10 covers some of that part. Yeah, Oliver, we started with 2-way tables. Yaya, when it comes to expected numbers, it really depends on the question. So have a look through the question before you decide. Jeffrey, if there's no, because they actually say justify with an assumption, minimum 1 justification. If you give no justification, that'll come up just as an achieved. Is there a histogram question? No. Yeah, I'm gonna do 1 more question after this, guys, and then I'm gonna wrap it because yeah, I'm starting to get a bit tired. I need to get the working for this only can be a graph. Now you can just draw like a quick graph, and I think you should be fine. Now I'm not going to be on tomorrow half. It's usually crazy time the night before the exam. If I do a stream, then it ends up being, yeah, it just ends up being a bit crazy. Lol, I think it's live on YouTube right now, so you can go on it and just start watching from the beginning if you want. 5 times as likely, 5 times more likely. I don't think so, Gayatri. I think they're pretty much 5 times as likely as it'll happen, 5 times more likely. Or 5 times less likely. 5 times likely, 5 times more likely, 5 times less likely. Yeah, I guess it's kind of the same, so... Not very high, Mia. Like, I'm sorry. Like, I did about 4 hours in the last... Since Friday. Friday I did 2 hours, and I did 2 hours. I think we did 3 hours last night, which was insane. How do you do these without a graphics calculator? Go check out part 4 of the probability in 10 hours playlist. I go through how to use the table. All right, I'm gonna go through this quickly, guys, because I'm getting it's been too long today. All right, so we've got normal distribution here. So we've got a mean of 1 minute and 24 seconds. So 1 minute and 24 seconds, that means the mean is equal to 84. And then the standard deviation is going to be 18. Now we're looking for what proportion of games can be completed between 1 and 2 minutes. So 1 is 60, 2 is 120. So we're going to write this up as something like this, 60 and 120. And we're looking for the probability that's here. So I'm sorry, I'm going to have to do this in the calculator because the table method is going to take me a little bit longer. But as I said to you before, the table method is available on that episode 4. So we're going to go into distributions, go to normal, and make sure we click on NCEA. And then we've got lower is going to be 60. Upper is 120, standard deviation is 18, and the mean is 84. So when we do this, we get the probability of it being between 60 and 120 is equal to 0.8860. So that's a nice achieved question there, and I think normal distribution you guys have to be able to get an achieved, right? Because all it is just putting the numbers into the calculator and getting that probability out. And I think sometimes you get some weird ones, but apart from that, that's something you should be really good to go. All right. Question number 2, we're looking for out of 4,210 games played, how many did she complete in less than 90 seconds? So once again, the mean is 84 and standard deviation is 18. And we're looking for probability of X is less than 90 first. So we're going to have 84 is somewhere there, 90 is somewhere there. So that means this probability is going to be above 0.5, that's for sure. So we're going to go into probability of X less than 90 is equal to. Now, when it comes to this, we're going to go to upper as 90. And for the lower, and I know that some teachers tell you to do different things. I always like doing this because I just go 1 times exponent 10. Because that just goes, that's like negative, what is it? Not a trillion, is it? I don't know. I can't work right now in my head. So as you can see, the probability is 0.63056. So that's 63056. So out of 4,210 games played, we're going to multiply that with 63056. You could tell I'm starting to lose focus. All right, so we've got 0.63056 multiplied by 4210. Now, here comes an answer 2654.65. Now, how many games did she complete in less than 90 seconds? Now, I know in the answer schedule they say you can accept 54 or 55. In this case, I would probably write this as 2654, because at 55 it would, like at 2655, some of the games there's a slight chance that it's actually not less than 90 seconds. So in this one I would actually round it down, because 26, so imagine it like this: if this part here was 2654, then 2655 might be just over it. So that's why in this case I would actually go with that's why I'd go with like lower number in this case. All right, so looking at question 3, what is the maximum time she takes for the quickest 5% of the games she completes? This one is going to be a merit one, I reckon. So we're looking at this part here, which is 0.005. So our mean is still 84 and our standard deviation is still 18. And it's interesting because, like, I mean, you can just do this straight in the calculator again. So you can go to stat mode, go to distributions, normal, inverse normal. So we've got the left tail. The area is going to be 0.05. And then we're just going to leave the standard deviation and the mean as the same. So when we do this, getting 50, did you guys get 54.39? Yes, you did. Crumb, we did some questions earlier, so if you just go to the start of this tutorial, you should be able to catch that. So we can say probability of x less than, I don't know what I'm going to call it. I don't know, k is equal to 0.05, and then we can say k is equal to 54.39. Now this is, the tail's going to be on the left because it's telling you that it's the quickest. So if you think about it, quick time generally means that your time is going to be smaller, because that means that you're actually going faster. Because if you look at the left tail, that's telling you 5% of the slowest games, because that's taking more time. Now, I don't think you get marked down for 54. I think you'll be fine. Please help us, Chahas, because I struggle with some of these questions. So if I stuff up somewhere, please just yell out in the chat to go, hey, you did that wrong. All right, one last question for the night team, and then I'm gonna call it. So we've got C1. Where is it? Hang on, give me 1 second. I just gotta try and find this question. B3, which we did. B3. Looking at the wrong question. All right, this is the last question for the night. We're going to do one of these find the standard deviation questions. All right, let's go to the next question, team. This is the last question for the night. A good old standard deviation one. In the calculator, you're just going into menu, stat mode, which is number 2, and then you go into distributions, go to normal, inverse normal, and then you should be able to put it all in there, and then you should be fine. Mimi, I would actually, I know I was being lazy in the previous question. I would have actually put down that whatever you just written there, z equals x minus m over the standard deviation. It's a good idea to do that, even if you use the calculator, you can still kind of show the marker that you know what you're doing, especially for those ones. To calculate the standard deviation, yes, it's x minus the mean divided by the z value. This one, Jeffrey, you shouldn't be rounding up, because this is standard deviation and you want to have it as accurate as possible. So you definitely do not want to be rounding up or down for this. The formula will be given to you guys in the exam, the z minus. If you want to know where it is, you will find it. So in your formula sheet for the normal distribution, you should get, there we go. Right there, that formula should be given. So if you want to do the standard deviation, you're just kind of rewriting this formula. So you just rewrite this as standard deviation is equal to x minus the mean over z value, and that's it. That should pretty much sort you out for that formula. Every time, Dumpling, every time. All of those things that you mentioned, Pates. Right, so drawing the graph, I'm going to have the graph that looks like this. Finds that 6% of the graph, 6% of the games is completed in 105 seconds or more. %. Okay, so that 87 is here, 105 is here, and then the 6% is going to be that part there. So first, we know that this is 0.06. We just need to figure out what the z value is. Now, when you want to figure out the z value, again, we're going to be using inverse normal, but the thing is, if you want to figure out the z value, you need to change standard deviation to 1. Actually, in this one, we've got the right tail. So I'm going to put right tail and then 0.06. Standard deviation is 1 and the mean is 0. So when we do this, we actually end up with z is equal to 1.554. Now, finding the z value is going to be, I guess you can kind of, it's all right. Let's just finish the question. So then standard deviation will just be x, which is 105, minus 87, divided by the z value, which is 1.554. So we've got 105, take away 87, and then divided that by 1.554. That's going to give me a standard deviation of 11.58 seconds. Now, really important that you don't actually round up this value or round down to like a whole number. You leave it as 11.58 seconds because, because if you put it as 12 seconds, then I think you will find that it'll be incorrect. How do you find the inverse section in the calculator? You just go to menu, go to stat. So that's in the stat mode. And then you go to distributions, which is normal. Then go to normal distribution and then inverse normal. Now you're welcome. How do you know this is the right side? That's because if you look at the mean, right, the mean is 87. Because the mean is 87, you kind of know that this is where the middle is, and then it says 105 seconds, you know, so that's going to be on the right hand side. Now you cannot, it's actually saying 105 seconds or more, which means it's going to go this way, and that's how I know it's on the right hand side, because it's 105 and more. Giorno, thank you, but you didn't have to, but I appreciate it. Jax, yeah, you could, if you have a rounding error, then you'd come up to like 11.61. So it is possible that you end up getting that. Let's get rid of slow mode. Nah, Jeffrey, I wouldn't round up or round down any of the normal distribution ones unless they say it's like a whole number question. If it's a whole number question, then I would. There we go. There's my little mistake there, Jack Shearer. I think Candy Corn, you can just click on reset, like right at the bottom of your calculator. There's a little systems button there, and then you can just click on reset, and then you should be good to go. All right, team, look, it has been a crazy 3 days of me doing non-stop level 2 maths. I can't believe I'm actually going to do this for level 3 next week. That's going to be insane. Yes, Pansy, shout out to Mr. Anderson. Well done. Can you stop spamming now, please? Otherwise, my mod's going to block you forever. How did I find the set values, Afina? You might need to come on YouTube and just rewind and watch. Hey, look, just a bit of final words from me for you guys that are doing all the 3 exams on Tuesday. Now, I'm going to be straight up. I will be on tomorrow, but I'm going to be honest with you. I'm going to completely ignore every, Jesus. I'm going to ignore every level 2 kid that comes and goes, I need help with this, I need help with this, because me trying to run a tutorial on the last night before exam is never a good idea, because it just stresses a whole lot of people out. But at the same time, I want to kind of help out the level 3s and level 1s tomorrow as well. So yeah, so I'll definitely will not be doing level 2 tomorrow. Most likely be level 3 or level 1. I haven't figured out yet. But also I need some shut-eye. So I might just sleep for once a bit early. But yeah, look, with the exam questions, I know like a lot of people go, which one should I do first and so on. Entirely up to you. Like, don't try and do like the hardest, well, whatever standard you find hard, don't try and do that first, because that can sometimes be demoralizing. So try and do the easy, or the ones that you find easy. And for some of you, it'll be algebra. Some of you, it'll be calculus. For some of you, it'll be probability. So you got to figure out what's actually best for you. All right. As for the rest of you guys, like and also another thing, if you're doing calculus and you're like, oh, I just want to get to an achieved, just look at the question and go, if you can just do differentiation, or if you just do integration, you most likely could get an achieved with that. The algebra one, I will always say this with the algebra, don't panic with the big, the big word questions. Take your time, and even if you just do halfway through those questions, you can easily get like an achieved or a merit. So yeah, so don't leave any question empty. I know a lot of people do that, get into the habit of it. So just don't leave any questions empty. And for the folks that have actually joined me for the last kind of few weeks, it's been awesome. Thank you so much for actually kind of hanging out and just doing these questions, and hopefully you got something out of this. Level 1 stream, look, I'll be back after Tuesday. I think Tuesday I'll have to spend some time with you guys because we'll do an exam catch-up session where you can come and just pretty much go, what was that question all about? So I'm sure we'll have one of those catch-up sessions on Tuesday night. But apart from that, good luck. You've got what do you got? You still got another 36 hours before your exam. Make sure you at least get 16 hours of sleep in that time, all right? Sleep is important, people. Don't stay up like till 3 a.m. studying on the tomorrow night. That's the worst thing you can do for yourself. And if you're doing level 3 calculus, I will see you next year. And if you're not, I will see you in probability at some point. I think it still is a good idea to do some work tomorrow, little devils. 100% Doc Doof. If you do remember the questions, you can give me, you can give it to me. I can try and do that, but otherwise, I will pretty much, what do you call it? Because sometimes the questions actually, questions come through, and some people give me the wrong questions, and then it makes it even more confusing. So, yeah. I could, Jeffrey, like I said, I don't mind doing a post-exam interview with you guys, but I would love to know what the questions look like, but I can't see it right. I think, Marissa, I might actually do level 3 probability in 10 hours or 15 hours next year because I just ran out of time this year. So could do it next year. How many words for written normal? I don't understand your question there, Dumpling. Yeah. Anyway, take care, team. I'll see you on Tuesday when you guys come back with your exams. I'll post a good luck message tomorrow for you again, all right? Yeah, as always, thank you so much for watching, and good luck. You'll be fine. All right, catch you later. Where am I ending first? All right, TikTok, see you later. I think someone's got... What is this happening? Sorry, TikTok, all of the lives that I do is actually on YouTube, so jump over there and then catch up there, all right? Catch you later. Bye. That's done. Oh, I'm still on TikTok. Sorry, I'm still on here. All right, see you later, team. Catch you.